Okay.
Good afternoon. Our presentation is how to classify monosaccharides. The monosaccharides follow three rules: the number of carbons in the skeleton, the carbonyl group, and the representation in the space around the carbon. I'm going to talk about the number of the carbon in the skeleton. We use the prefixes for the sugar, and it depends of the number of carbons they have in the skeleton, between 3 or 7 carbons in the skeletons. We use prefix like for 3 carbons, 3 oxes, and for 6 carbon hexoses, pentoses, etc. These are examples of the pentoses, hexoses, and issue of 1. Between the, we can have polysaccharides with the same number of carbons, like these are 2 hexoses? Trioses, but with different double indices with the oxygen, and the next one is going to talk about.
Okay, I will explain the other way to classify carbonites, that is the location of carbonyl group. The carbonyl group is a carbon with double bonds with oxygen and the rest of the molecule. There are two possibilities that we can have in a skeleton of carbon. We could have aldoses or ketoses. The aldoses are a skeleton with a carbonyl group in the end of the skeleton, and the ketoses have a carbonyl group in the second carbon of the skeleton. So that is the difference between aldoses and ketoses. The next way to classify carbons, I will explain my part.
Yes, well, I will talk about the last one. It's about the chirality of the molecule. It's about the spatial arrangement of their parts around an asymmetric carbon. What is an asymmetric carbon? It's a carbon attached to 4 atoms or a group of it. Here we have a carbon connected with an hydroxyl group, with an hydrogen, and we have here another skeleton that is different from here. So this is a chiron atom. So how is this? Where is the hydroxyl group? Is one sugar or another? We have 2 types of sugar, and this is called 2 enantiomers. D sugars and L sugars. These sugars have the group hydroxyl in the right, and we use D because of the Latin word for right, that is dextro. And we use left L sugars, when the hydroxyl group is in the left, and we use that because the Latin level. So that's it. Then we have all the possible monosaccharides that we have. Here we have 2 triosas, but they are an aldose and a ketose. Here we have 2 pentose with an aldose and a ketose. And here we have but we have here 2 enantiomers, a glucose and a galactose, because this is a D aldose and here is an L aldose. Thank you. Okay, but we did 3 because he was sick all the week, so we did 2. And he is here.